So finally, our last part of the lesson is on the word problems. Now, obviously I'm making the video at home. I do not have a paper copy at home with me of your notes here. So you should be looking at your notes, your guided notes. Okay, so we're talking about the rational equation work problems. Okay, all right, as you can see, the shared work problems has a specific pattern here. Okay, all right, it's going to be 1 over, usually it's the job over the time of each person. Okay, and you can see that in your guided notes. Okay, so it's 1 over the time of person 1 plus, because if they're working together in math means that you add, right? That same job over the time of person 2, and when they're together it's equal to 1 over x, where x represents the time together. Now these are pretty easy to set up, and using Desmos they're really easy to solve. The main thing you always want to do though is to make sure that when they give you your units are always the same. Sometimes they like to say an hour, sometimes they like to say minutes, so you need to make sure that everything are the same units. You can't have hour and minutes here. It'd have to be hour, hour, or minute, minute. Okay. All right, so let's get down to example 1. Okay. All right, it takes a boy 90 minutes to mow the lawn. All right, so E1. And obviously you can write this in your notes because you got the guided notes. I don't. So here in example 1, it takes the boy 90 minutes to do that one job. So that one job of mowing the lawn takes him 90 minutes. Okay. But his sister can mow it in an hour. So, all right, so plus the sister's time, that one job, an hour. Notice they say an hour, but we want minutes. So let's change that hour to minutes. How many minutes are in an hour? Well, we know that 1 hour is equal to 60 minutes. So we're going to put a 60 right here. How long would it take them in minutes to mow the lawn if they work together using 2 mowers? So that's 1 over x, what x represents our time together. All right, this is an equation. We're going to solve it using Desmos. We're going to do left side, right side. Notice right here I've got 1 over 90 plus 1 over 60. The left side does not have a variable, so I need to make sure I do y equals. So we're going to do y equals 1 divided by 90 plus 1 divided by 60. And then on the right side we got 1 over x, so we're going to do 1 divided by x. Alright, so we're going to look for where they intersect. Now, that's black right there, and it's kind of hard to tell the difference between the lines, so I'm going to change it to some colors that are a little easier to see. Let's do orange and make the line a little thicker, maybe about size 4, and change that from a black to maybe let's do green and make that about a 5 as well. Alright, so we can see the 2 lines here. Alright, what we want to do is see where they intersect. Now, I'm not going to look on the negative side because we can't have negative time. So I'm just going to look over on the right. So just tap your graph. Now, if you think about it, we got 90 and 60, so it can't be more than 90. Okay, so it's got to be less than 90 because if working together, it takes longer for them than one person, then something's wrong. So I'm just going to move it along the line until I find that little dot. You see the little dot right there? Click on that. How long does it take them working together? 36 minutes. So here x is 36 minutes. And that's it, folks. That's how you do these problems. You just have to know how to set it up. Alright, so let's look at example 2. working together, Bill and Tom painted a fence in 4 hours. So I got Bill plus Tom. Okay, so working that one job of painting. At this time, though, it tells you that together it took them 4 hours. So we're kind of like working backwards. All right, if Tom has painted the same fence before in 7 hours, how long in hours will it take Bill on his own? So that's our unknown right there. We've got our setup. We're going to use Desmos to do left side, right side. All right, so here I got 1 over x plus 1 divided by 7. And then my right side I've got 1/4. So that the right side does not have a variable, so I got to do y equals. So y equals 1/4. All right, I'm going to go back to my home screen, so I'm just going to hit the home button. Again, I know it's not going to be on the negative side, so let's just come right here and just tap our graph and look right there. We already see that. So it's going to take Bill about 9.3 hours. So here x equals 9.3 hours. And yes, it is that easy. All right, so let's let example 3 be you try. So pause the video for about 2 minutes. And let's get example 3 out of the way. All right, so let's see how you did. All right, on average, Mary can do her homework assignment in 100 minutes. All right, so we got Mary. And that one job of doing the homework takes her 100 minutes. Okay. It takes Frank about 2 hours. All right, so now I'm not going to put a 2 here because I got minutes. And notice it says how long in minutes. So we want to change that 2 hours to minutes. So how many minutes are in 2 hours? Well, 2 times 60 would be 120 minutes. Okay, so if they work together, how long would it take them? All right, so again, we're going to do left side, right side. The left side does not have a variable, so we got to do y equals. So we got y equals 1 divided by 100 plus, oops, I forgot the cursor to the right, plus 1 divided by 120. And then I got my 1 over x on the right side. So 1 divided by x on the right side. All right. Again, I'm not going to worry about the negative side of the axis because we can't have negative time. The biggest numbers are 120, so it shouldn't be more than 120 minutes. Okay, so I'm just going to cursor to the right and keep tapping my lines until I see that gray dot pop up. And right there we've got it. So it's going to take about 54.5 minutes. So here x is approximately 54.5 minutes. All right, on our last example here. All right, and looking at our last example, example 4 here. All right, we got 2 pipes can be used to fill a swimming pool. When the first pipe is closed, the second pipe can fill the pool in 9 hours. Okay, so we got the first pipe and the second pipe. So the second pipe can fill it in 9 hours. When the second pipe is closed, the first pipe can fill it in 7 hours. How long in hours will it take to fill the pool if both pipes are open? So that's that 1 over x. So again, we're going to put that in Desmos. All right, this side, the left side does not have a variable, so we got to put in the y equals. So we got 1 over 7 plus 1 over 9. It's not going to be more than 9 hours, so we're not looking at anything beyond 9. And notice right here, we already see that's going to take up, what, 3.9 hours? I think this one actually said 2 decimals, didn't it? Yep. So this right here is going to be x is approximately 3.94 hours. All right. Now, if you notice, you've got some problems to try on your own. So try those. Let's see what's there. There are 3 problems there dealing with the work rate. And then for 13 through 16, I want you to use Desmos just to solve it. Do left side, right side, and find the solutions. So if you'll pause the video here and work on those problems now. Alright, so I do want you to include these problems in your notes. Alright, so for that first example that you had to work on your own, you should have got X is approximately 1.7 hours. For number 2, you should have got X is approximately 2.4 hours. For number 3, now number 3 was probably the most difficult one. You should have got X equals 24 for Tom, and then Jerry would have been 12 hours. And then for the Desmos problems, for number 13, your 2 solutions were -3 and a 1. Number 14, you should have had a -1. Number 15, we'd have -5.7. And number 16, you would have had 2 solutions of 1 and 4. Excuse me, -1 and 4. Now, you better show me some work right here. No work, no credit for that one. So, and we're done. I know it's been a long lesson because we had 3 videos, 3 parts. Proportions, regular equations, and then word problems. But we're done. Woo-hoo.